Okay, so we're given f of x equals 9 over x plus 1, and we want to find the derivative of the function at a is equal to 2. Okay, keep in mind the derivative is the slope of the tangent line. Okay, so when we find f prime of 2, we're finding the slope of the tangent line. Okay, we also want to find the equation of the tangent line at the x coordinate of 2. Okay, what I would do, I would first want to know my y coordinate of the point that they're talking about. See, when they say a is equal to 2, that's the x coordinate. So 2 something is the point they're talking about. Okay, I got to find that y coordinate. So I would first do that. So my equation is y equals 9 over x plus 1. So my y coordinate I can find by putting 2 in for x. So that would be 9 over 2 plus 1. Okay, 9 over 2 plus 1. I'm going to make that an improper fraction. I'm going to think of 1 as 2 over 2. I'm going to think of that as point, or the y coordinate as being 11 over 2. Okay, so what we know is whenever the x coordinate is crossing that graph at 2, the y coordinate of that point would be 11 over 2. Okay, so we first want to then find the derivative at a. Okay, the derivative at 2. Okay, the slope of the tangent line at 2. Okay, so before we can find the derivative at 2, we need to find the derivative. So I'm going to rewrite the function. And what I would do, if I'm going to find the derivative of this function, I would rewrite 9 over x to be 9x to the negative 1. I think that's a lot easier to work with. So the original function f is 9x to the negative 1 plus 1. Okay, the derivative of x then would be, okay, 9x to the negative 1. The derivative of that would be 9 times, okay, the derivative of x to the negative 1 would be negative 1x to the negative 2. Okay, I could simplify that to be negative 9x to the negative 2. And then I could rewrite that to be negative 9 over, see, x to the negative 2 is really 1 over x to the second, negative 9 over x to the second. Okay, so that's the derivative. The derivative of x is negative 9 over x to the second. Okay, I want to find the derivative at 2. So I'm going to put 2 in for x. So I'm going to have negative 9 over 2 squared. Sorry, this is sloppy. But it should be negative 9 fourths, negative 9 over 4. Okay, so that's the first thing they're asking for. What's the derivative at a, which is 2? So negative 9 fourths. Okay, now to find the equation, we got of the tangent line. We need to think about this. The tangent line, the slope of the tangent line is this negative 9 fourths. Okay, so the slope of the tangent line m is negative 9 fourths. Okay, it goes through point 2, 11 halves. So if I want to find the equation, I like to just use a slope-intercept form, put in my slope of negative 9 fourths, put in my x and y value, and then find b. So I'm going to do it that way. So y equals mx plus b. I'm going to put 11 halves in for y. I'm going to put the slope of that tangent line in for m, negative 9/4. The x value is 2. Okay, solve that for b. Okay, so that would be 11/2 equals negative 18/4. When I multiply these together, I'm going to think of that as negative 9/2. Plus b. Okay, if I add 9/2 to both sides to find b, I would end up with, let's see, that'd be 20/2, which is 10. Okay, let me back up a minute. When we found f prime of 2, we found the slope of the tangent line at the point. Okay, we now know that the value of b, the y-intercept, is 10. So my final answer is just putting the slope of the tangent line in front of the x and putting the 10, the y-intercept, at the end. Okay, so y equals negative 9/4 x plus 10 is the slope, is the equation of the tangent line at point 2, 11/2. Okay, guys, I hope this helped. Thank you for watching.